Hi again, fifth graders. We're going to take a look at lesson 1.3 today, and this lesson has to deal with powers of 10. So I thought to start off today, I would show you this cool video that I came across called The Powers of 10. Now, I don't have time to show you all of it because it's 9 minutes long, but what I'll do is I'll post a link to this on your assignment. If you want to watch the whole thing, then you can go ahead afterwards and enjoy it. But the cool thing is this video was published in 1977. Wow, that was before I was born. But the information in it is still accurate as far as modeling for you how awesome and different the powers of 10 can be from just one place to the next. So they're going to use an example of ground level on Earth and then zoom out as we go through the powers of 10.
The picnic near the lakeside in Chicago is the start of a lazy afternoon, early 1 October. We begin with a scene 1 meter wide, which we view from just 1 meter away. Now, every 10 seconds, we will look from 10 times farther away, and our field of view will be 10 times wider.
So pay attention to this number
here. This
here.
square is 10 meters wide, and in 10 seconds, the next square will be 10 times as wide. Our picture will center on the picnickers, even after they've been lost to sight. 100 meters wide. The distance a man can run in 10 seconds. Cars crowd the highway. Power boats lie at their docks. The colorful bleachers are Soldiers Field. This square is a kilometer. A racing car can travel in 10 seconds. We see the great city on the lake shore. 10 to the 4th meters, 10 kilometers. The distance a supersonic airplane can travel in 10 seconds. We see first the rounded end of Lake Michigan, then the whole Great Lake. 10 to the 5th meters, the distance an orbiting satellite covers in 10 seconds. Long parades of clouds, the day's weather in the Middle West. 10 to the 6th, a 1 with 6 zeros, 1,000,000 meters. Soon the Earth will show as a solid sphere. We are able to see the whole Earth now, just over a minute along the journey.
Isn't that incredible? Going from just 1 square meter and zooming out by powers of 10. It only took 7 repetitions to get to the entire outline of the Earth. Now this video keeps going all the way to like 10 to the 15th power, so you can actually see the edges of the universe. And then later on in the video, it takes you the opposite direction, and we get back to the man on the picnic blanket, and it zooms in to see the very cells that contain the very secrets of life. So I thought it was cool going both in the positive direction into outer space and in the negative direction all the way to the very foundations of what makes life possible. So that's a cool video I just wanted to share with you. I will put a link on the assignment page if you would like to take a closer look. But getting back to today's actual lesson in the Sadler book, we're going to be using this place value chart to assist our understanding. This is a good resource that I hope you were able to download, print, and get into your notebook to have on hand. So just like the video showed, this was the base picnic blanket, 1 meter, and then it increased and zoomed out by powers of 10. So all the way over here, the 10 millionths place was where we saw the outline, the edge of the Earth itself. So that is really neat. Now going backwards would show you zooming in closer and closer onto the surface of the man's skin. You could see the cellular level and all of the atoms and different DNA components that make us uniquely alive. So that is a really cool activity to take a look at. As we get into today's material, you're going to notice that you are coming across some numbers that have this little tiny number up next to it. I'm not sure if you've ever seen that before, but that little tiny number next to the 10 is called an exponent. An exponent will give you an idea of what power of 10 you're working with. So let's look through this chart. If we were working with just the first power of 10, 10 to the first power, then that would only have a value of 10. But notice as the value up here increases, that digit, so do the zeros on the back. Are you noticing anything about the number and the number of zeros? What do you notice? That's right. The number correlates, this exponent number correlates with how many zeros are fixed onto the end of this 1. So something to the 5th power will definitely carry a bigger value than something to the 1st power. So let's practice looking at these patterns below. If I multiplied 52 times 10 to the 1st power, I would simply be doing the same thing as multiplying it times 10, or on this place value chart, hopping 1 place over from where it currently was. So if 52 was placed here and I did times 10 to the 1st power, it would become 520. See? And if 52 times 10 to the 2nd power means that I'm multiplying it times 100, that means I'm taking 2 hops to the left. So I'm starting here and taking 2 hops to the left. That means the 5 will be in the thousands, the 2 will be in the hundreds spot, creating the number 5,200. Same thing, 3 hops to the left would craft this number, 4 hops to the left would create this one, and so on. So you're going to start to notice some patterning within the powers of 10. Powers of 10 can be written in standard form or by using exponents with a base number of 10. So this is the exponent version, and this is the standard form version of the power of 10. If a base of 10 had an exponent of 0, that is equal to 1. So imagine that it had no zeros on the end. That would be equivalent to 1. So multiplying makes a number bigger, but what do you think dividing does? That's right, it makes a number smaller. So when I divide by powers of 10, instead of adding them on the back, what am I going to be doing? That's right, I'm going to be removing the zeros from the back. So let's look at this large number right here. That's 31 billion. If I'm dividing by 10 to the 3rd power, I'm going to be removing 3 powers of 10. So I'd be removing this one, and this one from the back, leaving this value of 31 million. Let's go ahead and practice together in your workbook. I'm on page 5 from lesson 1.3. Here's another reminder about working with powers of 10. Multiplying adds zeros to the back, while dividing removes zeros from the back of that number. Number 1, find each missing number or power of 10. So we're given the choice to write the standard form of the missing number, or we're given the choice to write it as an exponent with a power of 10, okay? So 1 times 10 to the 2nd would be the same thing as saying what? 1 times 100. There are 2 zeros in 100, which help you remember how many zeros to place on the back of there. Now careful, this one is division, okay? So if I were dividing 1200 by 100, how could I write that as an exponent? 10 would be my base. These are really small numbers. I wish I could make this bigger, but that's as big as it gets. And then I'm going to give it an exponent of 2 because I have the number 100. I'm going to give it a tiny 2 if I can. You can probably do it better on your paper than I can on my screen. All right, complete each statement. To find 14 times 10 to the 5th power, we're going to write how many zeros at the end of the 14. That's right, we're going to write 5. This is the amount of zeros that are going to get tacked on the end of 14. And what standard form number would that get me if I wrote it out and stretched it out? Let's type it there. 14 and then 0, 0, 0, 0, 0. I'm going to put some placeholder commas in there to make it a little easier for me to read. How's that look? 1,400,000. Number 4, to find 870,000 divided by 10 to the 3rd, I'm going to remove blank number of zeros from the end. How many zeros am I going to remove, class? Yep, I'm going to remove 3. So let me write in a 3 there. 3 zeros from the end of 870 to get 870,000 to get 870. Okay, so go through numbers 5 through 14 here, either adding on numbers to the back of this number or taking them away. If you need help, that place value chart would be really helpful. You can write this number on your place value chart and then practice either moving forward to make it bigger or moving backward to make it smaller, however many hops you need to go, okay? So I'm gonna pause my video now and fill in these answers, and I want you to unpause it as soon as you get these done so that you can check it against what I have here, maybe figure out any mistakes you might have made before you move on to the homework, okay? All right, if you're not done yet, pause this video so you don't see the answers. All right, check down this line of practice examples and check if your number got bigger with multiplication and if it got smaller with division, okay? So if you made a mistake, maybe check there first. And the second thing I would check is this exponent value. Make sure it correlates with how many zeros you either added or took away, okay? After you complete your homework today, I have a quick Google form exit slip for you to complete, and that is going to summarize lessons 1, 2, and 3. I'm just going to give a little quick peek at how you're doing with the material. Absolutely feel free to use the place value chart that I have been using in class. It looks like this. Feel free to use it on that Google form assessment, okay? And besides that, upload your homework workbook page for me and enjoy your weekend. This is your last lesson of the week. Great work, everyone.